So within the Navisworks environment, we have got a number of different ways to view our model. One of the most important one is so you can go to the View tab on the top, and then you can click on the windows. And here, one of the most important window is Selection Tree. So if I click on the Selection Tree, basically I could preview details of how this model has been constructed. So you can see that this hospital model which you are previewing, so let me, is comprised of a number of different drawings and data sets. So it's a truly collaborative effort. So it's not merely a very nice visual model, but it has a lot of details. So if we look at the data set on the selection tree, we could see that it had details such as structural columns, structure floors, foundation. So our work of a lot of different contractors, subcontractors, engineers have been brought together within this model. So if we want to preview any details in isolation, so for instance, I want to preview structural columns, I can do a right click and hide the unselected, and that would show me the scope of the work involved within the structural columns. Or if we just want to have a look at the mechanical ductwork, we could choose. So right. So one thing which is obvious is that this is very different from our traditional ways of working, where there are a lot of linear information flows. We did talk about over-the-wall communication, where drawings and data sets get passed from one stakeholder to another without any true collaboration. Here we can see a good collaborative effort, where not a lot of drawings and data sets have been brought together. Now, this is obvious that all of this would not happen by a magic. We need to have appropriate processes in place, so such as what coordinates we are using, what sort of a naming conventions we are using, how we are naming different objects within the model for this sort of a coordination to take place. So as it is said that BIM is only 10% or so technology, and it's 90% sociology. So there is a lot of social interaction and processes taking place between different companies to help produce a final product which could be used to support the collaboration effort. So this is what we learned, that the way these production models are produced by bringing together output from multiple disciplines is truly collaborative. Now we could see if we go on a home tab, there is a tool called Append. So we could bring the drawings and output from different disciplines, and using the Append tool, we add this information and to the existing model. Obviously, once we click, we are prompted to enter the file that we want, and then we could attach it to this model. Now, if we look, for instance, the file formats which is supported. So if I try to open a new file, you can see the variety of file formats which are being supported. So including Navisworks native file formats, and then 3D Studio, PDS, ASCII, CATIA, CIS2, MicroStation, DWF, Autodesk. Basically, we can take in a number of different file formats. So this is another way this true integration is achieved, by bringing in data sets from multiple different software. So very often within a supply chain, we cannot dictate. Everyone has to use, for instance, a Bentley's MicroStation software or Autodesk software. People may be using different sort of a software. For instance, structural engineers may be using their specialist software, but as far as those softwares produce outputs in a open standards or in a format which is recognized, here the file formats could be integrated, right? So here another thing you would notice is that these are models which are used to support the production. So we cannot change the layout. So for instance, the floor plans or the layout of the building. This because this is not BIM authoring tool. This is primarily the objective is to support the production task. So here, if you want to change any design parameters, that would not be possible. That has to be done in a native authoring environment such as Revit or so. Here, all that we could do is we could preview it. We can see how different items will be put together. Right, so this is another thing that we have to keep in mind, that the tool is used to support the production. It is not an authoring tool. Now, if we preview few details, and now as it is BIM compliant, so if we click on any object within the model, we should be able to see the property. So there is properties icon here. So let's try to open it. So as it is taking in the files from a BIM environment, all the data which is coming from the BIM authoring tool is retained to a certain extent. So for instance, here I am clicking on this glazed window and it is providing me with some details like a type information, which is the Revit material information, element ID, and maybe if there is some production information attached to it. So what is the time schedule when it will be put together, if there is any material information attached to it. So as we know that in a BIM environment, we do not draw anything. We basically drag and drop intelligent parametric objects. And these objects have basically got an Excel spreadsheet attached to it. So we have got full detail of what this object is. So all of this information to a certain extent is retained to support the production task as well. But here again, the emphasis is on having the right processes in place so that we have got information being fed into the model, that it makes sense so that others could retrieve it, others could make use of it. So as it is often said, rubbish in, rubbish out. If the information is not put in the right format in the first place, if we are not using appropriate naming conventions, making sense of the information could become very difficult. So for instance, in a complex project like this, the total size of the model could be more than 220 gigabyte. Now, if there is, and we have not used proper way to develop the model, it will be very difficult to make sense of it. So for this purpose, we try to organize information within our model. So here, for instance, if we look, the information is arranged in different sets. So which may be a way to break the whole big project into different work packages. So here you can see, for instance, the work is broken into plumbing, electrical, mechanical, site logistics, exterior walls. So if we have a preview of maybe an electrical works and hide unselected, so various electrical installations are shown, and right. So the sets is another way for us to arrange information within our model. Now, again, to support the production, it is important that there is some sort of a pre-production agreement. So, for instance, the way we are producing sets that could match with the key tasks. So we learned how to draw bar charts and Gantt charts. So perhaps this could be your key work packages, and perhaps for scheduling you could use. And then when it comes to mapping your schedule with the model, if there is some sort of an alignment, it will make the process of attaching your schedule with your model much easier. Okay, so here, for instance, if we want to preview the site logistics here, we would have only the information about these site logistics and the temporary elements of the site. So we can zoom in, zoom out to preview the details within our model. Right, so we are right now in the Home tab, and we are trying to explore different features which could help us support the production tasks. We did talk about properties. The other thing that you can see here is this clash detective window. So if we click on this, it basically allows us to run clashes between different models. Now, in a traditional work environment, basically we go on a site, and on a site we will discover that, for instance, there is a clash between the structural columns and maybe mechanical ductwork, and there is a physical clash between the ductwork and the structural column, and as a result, the work could potentially be stopped, and we will send a request for information to the designers to clarify this aspect. Now, with the features clash detection, we could try to preempt and try to identify the physical clashes. So here you can see that different types of clashes are highlighted. So either it could be a hard clash, where two objects are occupying the same space, and there is a physical clash. So this could be a case of your ductwork colliding with your structural columns. Now, if you discover this clash at a later stage, that could potentially cause the work to be stopped and create a disturbance. It could be possibly a critical task, resulting in a knock-on effect on your project. So if the whole idea is think before you act, and we could identify the potential clashes, so that once we go on site, we have run the simulation and we know that we have got maybe a millimeter level accuracy, and there are no issues. Then there are clearance clashes. So for instance, we would require certain tolerance and clearance for the ductwork or so we could specify that, and we could run that. So here, to run a clash, we basically identify which models we are running a clash against. So here we are running a clash, so we can choose selection A and selection B. So we are running a clash of a structural columns with the mechanical ductwork to see if there is any potential clash. So this could be possibly be done if we are meeting structural and mechanical ductwork, and to ensure that their drawings are talking to each other. So not only that people are engaging with each other, but people's drawings are talking to each other, and they are aligned to each other. This is again requires a bit of a change in the mindset, because traditionally in the construction we had this mindset that I know my job very well, and I've been doing structural work for past 25 years, and I'm certain of my capability. But here the issue is not your job, but how your job is linking with the contractors upstream and downstream, and to identify any issues. Now, to make best use of this, you would need obviously a good production knowledge, so how things are put together. So basically, once you run the clash, it could highlight number of different potential clashes. So for instance, here in this example, you can see when we run a clash of steel versus plumbing, it came up with 224 clashes. So it could be a painstaking job of going through this, because it's just a software. Software is basically identifying where is there physical clash taking place between two objects, and it could be a case of some of these clashes should be ignored, because that is what is expected. There will be some joints between steel and plumbing, so it's a case of those with a good knowledge of production to go over it and see. So clash detection is a good tool which allows us to do a lot of thinking before we go on site. Now, if we see in this example, particular example, results of the clash. So here within Windows, there is a save viewpoints. So save viewpoints are very much like different perspectives of your model. So you can think of it maybe sort of like an image of a model from a different perspective. So here, for instance, we have run the clash detection, and the output of the clash detection is stored in this folder. And here we can, let's take an example of mechanical versus plumbing. And if we preview the clash tests that have been saved for maybe further discussion in a meeting with mechanical versus plumbing contractors, so different issues are highlighted. So for instance, if there is any issue, then we can go on a review tab. We could be previewing it on our tablets or so. We could use these tools to draw a cloud and maybe add a tag to the model. So this could be potentially be sent as an attachment or a file, so that we can ask the mechanical contractor to identify the clearance which is required, or we can assign a comment. So the whole idea is to use the model to promote collaboration, to raise any requests for information, and to allow us to anticipate the problems well ahead of putting a single shovel on the ground, so that we could identify key issues. Right. So this is the clash detective, and also in the handout you would see that in the second session delves more deep and provides you with some exercises to explore this thing in a bit more detail. The other things, Timeliner, we will delve slightly more deep into it. So I will leave it to the last. And then we have got this quantification tool, which basically helps us in quantity takeoffs. So we could, for instance, preview how many doors are within the model. We can quantify maybe the materials being used. Now, this is again becoming quite important with the talk about sustainability and reducing the carbon footprint of construction. And we will see more and more importance of quantification of the model. So not only looking into the geometry of the model and clash detection, but also quantification from different perspectives. For instance, what is the carbon footprint of this model, and what are anticipated greenhouse gas emissions of if we use method A, or what would be possibility if we use method B. The other features include things like rendering, which allows one to render the model in different ways. So here, for instance, you can preview the rendering window, and you can see from within the library, you could produce different sort of renderings. So for instance, different types of finishes, flooring, fabrics. So it is possible to produce photorealistic animations. So for instance, you have produced a 4D model and you want to communicate it with your local community of different phases of the project and what disturbance it would have. You could produce good quality rendering, so you could use it to communicate. So this is the rendering tool, and then the animator tool basically allows us to create animations. So for instance, if we are producing a site logistics plan, we could produce an animation of the crane movement and the logistics and movement of the vehicles on the site, or some health and safety planning. So we could plan in advance maybe the fire safety, key exit routes, site facilities, things, so on. So animator tools allows us to produce animations from this model, and then we can do some scripting and right, and then also we could link the model with the data tools. Okay, so in the future, the vision is that we would have our models located on the cloud, and there will be some sort of linking between the physical world and the digital world. So this concept of a digital twin, which is now coming to the fore. So the idea is they have got maybe live information coming from live sensors to the digital model. So in a traditional models, there is a bit of a divide. So the models are not connected to the physical world. But now with increasing use of technologies such as 5G networks and Internet of Things, we are seeing this concept of what is called digital twins, where we would have a full physical replica, digital replica of things that are happening on site. So we could run different sort of simulations, experiments, and then feed this information back to the real world. So this bridging the boundaries, right? So within this software, I think the capabilities are pretty limited. You could connect it with different data tools, but in the future, that's a space to watch, and we would see a lot of integration between the physical world, maybe using intelligent sensors and tags, RFID, or so with the physical model. Right, so one thing of interest is this timeliner window that allows us to produce the 4D modeling. So let's close the window so we could have a better overview of the 4D modeling environment. So here you can see the project plan has already been attached with the model. So we are all familiar with the bar chart and how do we draw a bar chart. So you would be familiar with all of these columns, such as the task name. Okay, so here you could see sort of like a work breakdown structure, very neatly organized. So here all the summary tasks are presented in the black, and all the subtasks falling within that are indicated in the color. So you can see we can use this to have a slightly zoomed in or zoomed out view of a model, because as our project become more complex, we would like to have maybe a higher level view of maybe what are the key work packages, and then we can zoom in to each. So you're already familiar. Now this is the status column, which basically indicates what is the current status. So suggestion is we are not using it merely for planning purpose, but also for monitoring purpose. So this is the plan start or the plan end date, and we can also stipulate the actual start and the actual end date. So we could do some sort of a monitoring. Now it's also possible to use some sort of like a color coding, and if we are running behind schedule, this could indicate produce using the traffic analogy, could indicate the tasks that are in the red zone, or if it is within the planned zone, it would be green or so. So we could have maybe planned and the tracking Gantt charts, as we previewed in our previous session. Now the task type, so it is usually the software classify the tasks into different categories. So either it's a construction task, so is it part of the fabric of the building, or a demolished task, or a temporary works, or existing site and buildings, or construction equipment, or so. So one could indicate what type of it. So for instance, excavation of site is a part of a demolition task, right? So the next column is the column which basically makes this model as a 4D model, right? So this is where we are connecting this task. So for instance, project's task start is a task which has got no attachment with the model. However, the mobilize and secure site has been linked up. So here, for instance, this higher level task, which is indicated here, is linked with site logistics or existing task, right? So the way to do this linking is that we go to view and then we go to so let's go to our properties here, selection tree, and so let's randomly select. So for instance, I'm selecting this interior wall, which is currently selection, and then I will perhaps select a task which, let's assume, if I want to connect this task shell to this, I would do a right click here, and I will have the prompt that what I want to attach with this task, which component of the model. So I could highlight which I could select from here. So I could have this attachment of the particular aspect of the model with this task, right? So this way we would be linking our task, and this attachment is what makes our project plan a 4D model, because then we are linking it with the 3 dimensions of the model. And okay, so here this is the attachment bit, which is very important to convert ordinary project plan into a 4D model. And lastly, you can see the costing information, right? So if we have got a costing data available, we could include that information into it. So there are a number of different ways how we could bring in the plan into this environment. So the first thing is to how to draw a bar chart, right? So we could bring the data from an external source. So here, for instance, you could see that MPP, which is a Microsoft project file, has been imported, and then it has been mapped. So you could bring the bar chart or your plan, which is developed in a different dedicated scheduling software within this environment. So if your plan could have been developed in Primavera or Microsoft project, or you could use any other scheduling software, and then you can export your plan into a CSV format. It's a comma separated format, and then you can import it within this. So this is one way through which you can generate a bar chart, and then you could link it. Or if you want to, all you want is a very simple production of maybe a 4D simulation, you could generate the tasks automatically here. So for instance, there is a feature here, auto add tasks, and we can give a command to the software that you generate auto add the task for every set. So basically what the software will do is it will read all the sets here. So for instance, these are the key sets, and it will automatically generate the tasks corresponding to these sets. Thus you can then adjust. So here, once you have automatically generated tasks, then you can go and adjust the timeline as you see fit. So directly through visual interface by interacting the time boundaries, or through the plan start and the plan end date. So we did see that we could bring in the tasks either by generating the tasks within the software environment or through the external sources. And okay, and then there is a simulation column, which basically helps us specify how do we want the simulation to run. So here, for instance, we can see the settings of the simulation, so we could specify. So it is important that there is relationship between the dates. So you would specify the start date of simulation and the end date of simulation. So you could have been looking at into weekly look aheads, or you could have a 4D simulation of your entire project. Then you could specify what do you want to see in your simulation. So for instance, you could see planned against actual. So what we plan and against what we are delivering. So this could be a useful tool if we are using this 4D simulation for monitoring purpose. So here we are just want to see what is the planned schedule of this project. Then and the overlay text, so we can specify the information. So what do we want to see? So here you can see the top line when the simulation is run will display the day and week information. The second line will display you the task information. Third line will display you the material cost information. Fourth line will display the labor cost. Fifth line equipment cost and the total cost. We can add any other information. So for instance, if I want to add some additional information I want to preview while I'm running the simulation, I could, for instance, go here and so we could insert a new line, and then I want to see, for instance, the number of days since the start. So this is the, and then I can specify the color. So maybe I want to have preview this information in green color, right? So we would specify how we want to view the simulation, and once it is done, then we can play the simulation. So here on the top, you could see the simulation being run, and you should be able to see the information that we provided. So here you can see the timeline is going at the bottom. I'm overlay text at the bottom. Okay, so so you can run the simulation, and the overlay information should be displayed in parallel. So there could be a number of different objects for the simulation. You could possibly use it to maybe communicate this information with your local community, for which you would just need a granular view of it, and you could pause your simulation at different points and could explain maybe to your local stakeholders the key phases of this project, or you could have it at a more micro level for maybe a weekly or a monthly look ahead planning and exploration of different options. So in this we did explore different. Now for a lot of software, you would see there are different features that help you explore. This is consistent with different software, so you can have a different perspective, maybe from the top or the bottom, so you can have different views. And there are features such as avatars, so you could have maybe a digital walkthrough through your model. So there's things here that allows you to walk, and you can define a third person walkthrough, or you can have an eye level view, or you can rotate the model in different ways. So very typical of all the visual software. So that's the visualization is one key feature. Now, if we look at the other example of the model, so here, this was an example of a hospital construction. We will now look into the other example, which is so. Right, so if we go back to the exercise that we were talking about, so in this exercise, you're prompted to download this very simple model, so not as complex as the hospital model which we were previewing just now. And right, so the other example which we would like to preview is that of a high-vis construction. So this is a locally significant high-vis project, and so for learning purpose, the output of this model is shared. So if we look at different views of the model, different structures, it is again a simple high-vis construction involve a number of different contractors, number of different structures, different their layout. So coordinating all of these activities and managing the production is a key challenge. So in this example from the real life project, you can see how design teams brought in output produced by individual engineering teams together in a one format. So here the tools could be different. You could be using tools such as InfraWorks or Civil 3D to produce the road layout and the bridge design. And again, the principles are the same. And right, so this is another example that students could preview. Now, for for students to get some hands-on experience, this model was shared. Now, if we see through this model, it's a very simple building, very simple structure, and students were encouraged to explore different ways of producing a 4D model for this project. So if we check the timeliner window of this model, and let's so here we can see that there is no task identified, so we could possibly start by generating some tasks. So either we could add the tasks here. So so there could be a number of different ways. Okay, so let's start by adding a few tasks. So one way could be for us to look into the maybe how different objects have been stored, and maybe if it is mapping to the key work packages, we could prompt the software to generate a task according to it. So if I do a right click here, I can ask the software to generate an automatic task list for every set in the model. So it will basically read the sets within the model, and based on this, so things such as starting with site work. So you can see there is a mapping here between the sets, and the tasks have been generated. Now software has just given a 1 day duration. I can manipulate these dates directly from the window. So for instance, I can maybe have manipulate the Gantt chart visually to specify some realistic time scale to it, or I could just give, starting from 2nd of March, maybe a 10 days duration, and then copy this date and pasting it here, and then taking it further 7 days or so. So I could either manipulate the bars within the Gantt chart visually, or we could specify the date. So this is one way to generate the 4D model, where we look at the sets, how this model has been created, and prompt the software to generate a task list corresponding to the sets, right? So we, if this example, just delete it. The other way could possibly be, we could look into the way how this model has been structured. So there are, for instance, the model is divided into different levels. So for instance, if I want to see the structural details here, I would hide the unselected, and I could see the structural work involved in this. Or if I want to have a preview of columns information. Okay, so we could, the other way could be a look at the top level sets. And so if you go back to the timeline row, and we can prompt that automatically generate the task list for every topmost layer, which is shown here. So you can see this example has 5 different layers, so it will generate a task list from here, and then we can manipulate the dates. And okay, so this way we generate our task list. And okay, so once, and the other way is you could possibly have a Microsoft project file. So you would bring the data from an external file. So if I prompt a Microsoft project file, it would prompt me to import the data from an external source. Once we have this information, the next thing will be to maybe run a simulation, right? So here we could simulate the text, and here on the top you could see some information is, so this information is controlled by this settings box. We can specify what information we want displayed. So we could overlay the text. So for instance, we can create a new line, and maybe in the next I want to display the total cost of this project, and I can specify it should be displayed in a blue color. And then I can also want to display information of the currently active tasks, and I would like it displayed in a maybe a black color. Okay, so once I have specified so here you could see, and the cost information is shown on the second line, and the currently active task is shown here, which would indicate basically the progress of the work. So we could run the simulation, we could see it is presenting the data alongside here. Right, so if we go back to the tutorial, in the first task, it was prompted that you look at your selection tree and notice the hierarchy and how it is using a Revit model. So we could have basically a preview of what is being done here. So we saw that we could automatically add different tasks using different layers, and then we can edit the start and end dates. So we could do it manually, and then we can copy the early finish of the previous task and then make it the early start of the subsequent task by copying and pasting feature. Right, now one thing to note here is this is not a scheduling software, so it will not be telling you what is the critical path or so. So this information and optimization of the schedule needs to be done in an external scheduling software like Microsoft Project or Asta Project, and here you will just bring the task. So the schedule has been optimized, and so here there are no capabilities to do critical path analysis. So here you can see in this demonstration, we have identified the tasks, then it is automatically attached, and because we have generated the model right from within the model, so then we can specify what information we want. So here it's important to specify this project start and the end date so that simulation runs in the correct time period. We could choose what information we would like displayed as the simulation is run. So here we have chosen currently active tasks. We can change the font colors. Okay, so here is this is because the layers and items created from Autodesk Revit. This issue can be overcome by simply creating the sets of the items in the model and making sure they are organized in the right sequence in the sets window. Again, highlighting the importance of the processes in place so that the tasks are in the right order. So here we remove the previously generated tasks and look at the key sets which are part of this model. So these sets could be used as a basis of automatically adding the tasks. So we will specify the key sets. This could be corresponding to the work which will be done by different subcontractors. Again, we need to specify the project start and the end date. So here you can see it's a more sequenced and more logical presentation for the work, and the project will come together. Okay, so we could attach the simulation with the linked viewpoint. So for instance, we want to have a camera rotation as the simulation is being displayed, and so we have done a rotating camera simulation of the project. So we can insert a new task if we have to. So in this example, we are bringing in an external scheduling file. So maybe we've done it in a scheduling, and we're bringing in the comma separated file. So you will see that this file has got no attachment to the model. So the attached column is empty as it stands. We could then specify the task type. If all the task types are of construction type, that is specified here. So here the mapping is done based on same names. So site works files, if we have got we have mapped the tasks from an externally sourced file with the sets which have been predefined. And for those items which were missing, and select so we have selected the items where they have furniture. So there are no other furniture items anywhere else. So after selecting those, we would do the attach current selection. So this will be attached to disk. Here in this timeline or columns, we can choose what costs that we want to display. So here is the case of manually inserting the tasks. So we basically want all costs, including material, labor, equipment cost displayed alongside the total cost data. Okay, so here in this simulation, we could see on the top the material cost, the labor cost, equipment cost, subcontractors cost at any point of time in the project. So in comparison with the traditional scheduling, traditionally a lot of connections are taken in our mind. When we talk about work package, we visualize that, well, this is my furniture task, or this is the foundations work. Here, a 4D or 5D environments allows us to connect all of this information together. So putting it everything in one place. Right, so here we are attaching the scripting information, so we can plan our site logistics and in a simulation see it alongside the 4D planning. So this could indicate how, for instance, our site logistics would change as the project progresses on the site. Or so by defining crane as a demolition task, it is removed towards the later stages of the project. Right, so